2, 1, mark.
3:55.
The countdown clock is resumed and we are proceeding towards an 8:38 a.m. Eastern liftoff.
Three minutes.
Securing LO2 topping.
Atlas tanks to flight pressure.
250. FTS internal.
T-minus 2 minutes, 30 seconds and counting. Once the rocket lifts off, it will only take about 78 seconds to reach Mach 1, or the speed of sound.
$159.
Vehicle internal.
$155.
Launch sequencer start.
$150.
Securing Centaur LH2.
Securing Centaur LO2.
$140.
FCS launch enable.
FTS armed.
T-minus 1 minute, 30 seconds and counting. The launch vehicle, payload, vehicle, and ground systems and Eastern Range are a go for launch.
120.
OCUs armed. FCS count started.
110.
Vent valves locked.
60 seconds.
T-minus 1 minute.
$40.
Stable at step 3.
T-minus 30 seconds.
25.
Status check.
Go Atlas.
Go Centaur. Go GPS.
20. 15. 10.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. RD-180 ignition. And we have liftoff of the United Launch Alliance Atlas V rocket carrying the 12th GPS 2F satellite for the United States Air Force. The Global Positioning System provides worldwide positioning, navigation, and timing service for military and civilian users.
Control.
You are hearing the voice of Marty Milanowski, here providing launch vehicle ascent data.
Speeds and injector pressures continue to look good. RD-180 continues to perform well. And the roll program is now complete. Body rates look good. Engine performance continues to look good as well. Coming up on Mach 1 momentarily. Mach 1. Body rates continue to look very good. Engine performance is steady. Max Q, booster has throttled back as expected. Engine signatures look good. Body rates continue to control right down the middle. Current altitude is 13 miles, downrange distance 8.5 miles. Current velocity is 2,200 miles per hour. Booster performance continues to look very good. Body rates are smooth. Coming up on our closed loop steering segment. And closed loop steering has been enabled. Also a minor roll. RD-180 pump speeds and injector pressures continue to look good. Our CS pyro valve has been fired. System's now pressurizing to flight levels. Signatures look good. Booster performance continues to look very good at this point. Pitch yaw on roll, controlling right down the middle. We've ended the Q alpha limited steering and throttled back as expected. Engine signatures look good. Coming up on our 5G throttle segment. And we have begun throttling to maintain 5Gs. Boost phase chill down is underway. Signatures look good. Pump temperatures are as expected. And we've begun throttling to 4.6 Gs in preparation for BECO. Boost phase cool down is complete. And we have BECO. Engine shutdown looks good. And we have stage separation. Looks like a clean SEP. We have LOX and fuel pre-start on the RL-10. GN2 purge firing is underway. We have RL-10 ignition and full thrust. Coming up on payload fairing jettison, and we do have indication of a good payload fairing jettison. All signatures look good at this point.
This is Atlas Mission Control at T plus 4 minutes 40 seconds. We've just heard Marty Milanowski report the successful execution of the events comprising the early part of today's mission, and all systems to continue to operate nominally. The mission is currently in the first of 2 Centaur engine burns. Our next event, Centaur main engine cutoff, will occur in approximately 12 minutes. I'm now joined by the Air Force's Lieutenant Jason Fischbach from the Global Positioning Systems Directorate. Lieutenant, thanks for joining me today.
Thank you for having me. It's an honor.
Great. Can you tell me just a little bit about yourself?
Okay, as you said, I'm Jason Fischbach. I'm from the Republic of Panama. I come from a family of enlisted veterans. I'm married. I have 2 wonderful sons. When I was growing up and we didn't have enough money for college, it became an easy decision to join the Air Force. So I joined the Air Force about 18 years ago, and after balancing school and work for about 15 years, I finally earned my bachelor's degree in electrical engineering. Shortly after that, I became the first person in my family to become a commissioned officer, and I've been working with the GPS Directorate ever since. I started off 3 years ago with the GPS Directorate. The first 2 years I worked as government lead for the GPS 2F production line, and that was an awesome opportunity. I saw everything from every stage of build and test of the GPS 2F satellites. Then I went on to what I'm currently working, which is the next generation command and control system.
Great. Well, congratulations on all you've accomplished so far. That's quite a feat.
Thank you so much. I really appreciate it.
Since you're very knowledgeable about the GPS program, can you kind of give us a current status on the GPS constellation?
Of course. The GPS constellation remains stable, healthy, and robust. With 30 operational satellites on orbit, the constellation is comprised of 19 GPS 2R and 2RM satellites and 11 GPS 2F satellites. The GPS 2R and 2RM satellites, also known as the GPS legacy satellites, have exceeded their life expectancy. In fact, 18 of the 19 that are on orbit today have exceeded the 7.5-year design life. Regardless of that feat, they continue to provide reliable position, navigation, and timing services.
That's great. You know, I'm really glad because of the lifetime of the satellites is kind of ending here. I'm glad we're helping you launch a new one today.
Yes, the GPS 2F satellites are vital to the modernization of the constellation, and in order for us to maintain the level of reliability and precision that GPS delivers to users worldwide each and every day.
Can you tell me about some of the capabilities that the 2F satellites bring to the GPS constellation technically?
Of course. The 12 Boeing-built GPS 2F satellites have improved signals, which will enhance the precision of the global position navigation and timing services provided both to support both the warfighter and the growing civilian needs of our global economy. The GPS 2RM was the satellite that directly preceded the GPS 2F satellites, and it introduced the L1 signal, one new L1 signal, and it introduced 2 new L2 signals. The GPS 2F satellites introduced one new L5 signal. So L1, L2, L5, what all that means is it's just basically a portion of the frequency spectrum. The L1 signal carries probably the most commonly known signal, the L1 course acquisition code, and that's the most commonly known because that's what you're going to have on your GPS watch, your GPS navigation system in your car and stuff like that. The L1 also carries a code called precision code, PY code, and that's for military applications, and it also carries L1M code. The L2 frequency carries L2C, which is a modernized civil signal. We'll talk about why that's important here in a sec. The L2PY, precision code for military applications, and L2M for military applications as well.
Great.
The L5 signal, which is brought by this GPS 2F, is safety of life. It's going to be used for safety of life applications, including aviation applications.